Okay, hello. So now we're gonna look at linked list problem called as a linked list cycle. Basically, we have to detect if there is any um, cycle present inside the linked list, right? If there is a cycle, we have to basically return true. If there is no cycle, we have to return false. So this is the basic, we can say, diagram. So I will just draw it right over here, right? So let's say there are four nodes and those four nodes are connected, and let's see, there's a cycle between the fourth and the second element like this. Okay, so let's say how can we identify if there is a cycle present or not. One way is basically we use hash set. It's like we are basically getting a duplicate values. Okay, so for finding a duplicate values inside an array, we basically traverse through the array, we store all those traverse elements inside a hash set. And while traversing, we check if that element is present in the hash set or not. If it's not present, then we basically add that element inside. If it's present, then we report that the duplicate number present inside it. So that same concept we can use over here as well. So as we are traversing through the linked list, let's say the first element. So if we'll check if this node is present inside the hash set or if that node is present, then we can say that there is definitely a link. Definitely there is a cycle present because if after this value, if then again we are going to this second value, and the second value is already present in this inside the hash set, that means there is a cycle present. But so this will definitely take off and time complexity, which is good, I guess. But it will also take off and space because we are gonna store each and every element as we traverse through, right? Each and every node. Rather than that, there's a better approach that we can take is of fast and slow pointer. So what is this fast and slow pointer? So we also call this as Floyd hair and tortoise algorithm, right? So what we're gonna do is basically we're gonna initialize two pointers. First, we're gonna initialize both the pointers initially at the head of the linked list. Fast, let's say this is slow and this is fast pointer. Then what we're gonna do is basically we're gonna move the slow pointer by one step. Okay, one step. But at the same time, we can also gonna move the fast pointer by two steps, one and two. So let's say at the first iteration, slow moves over here. Okay, fast will be jumping two steps. So it will eventually go to the third element, right? Now in the second iteration, slow will move here at the third position, right? So the slow will go here and fast will move two positions. This is one, and this will be the second jump, right? So fast will be coming over here. Now, in the fourth iteration, slow will come over here, but the fast will jump two positions, one, two, and fast, if you see, will also land on the same node. That means there is a cycle present because if let's just assume, okay, let's just assume there is no cycle present inside this linked list, and simply the last limb, let's say there's if there's no link present between these nodes and the last element is just pointing to the null value, then eventually we run a while loop will obviously store a condition that eventually the fast or fast dot next, if it reaches the null value, then that means the linked list has ended. That means there is no cycle, right? Because fast will always be ahead of the slow. And if there is no cycle, the fast and slow will never meet each other or overlap each other. But if there is a cycle present, then obviously the fast will move, traverse the whole, we can say the cycle, and eventually there's the slow pointer. So let's say if we take a cycle over here, let's say this is a circle, this is a cycle, right? And let's say this is a start point where the slow is present. And let's say there's another point right over here where there's a fast pointer present. Okay, so there's a gap we can say there's a gap between the fast and the slow pointer. Let's say the gap is of some integer value, right? And the another gap which is right over here, because fast and slow are going in this direction, right? The forward direction. So let's assume there's the distance between the fast and slow to catch up is, let's say, 10, right? Um, okay, and this distance is 10. So how much iteration will it take for the fast and slow pointers to overlap each other, coincide with each other? So as we know, slow moves by one step, whereas fast moves by two steps, right? So let's say after this iteration, the distance, let's say slow moves over here, the next step, okay? So now the distance will increase by one, right? But we also have to move the fast pointer. So the fast pointer will jump two positions. There's one, two. The fast will come over here. That is, fast is moving ahead by two positions, right? So that means now the distance is being reduced by two, right? Because fast is moving ahead. So eventually the total will boil down to 9. That means after each iteration, the distance between fast and slow pointer is reducing by one length, because slow and fast basically moves with a gap of one, right? And eventually the gap increases over time. So because of this, the iteration will that it will take 10 iterations, right? Because eventually this fast and slow pointer will coincide, and we can say that if fast and slow pointer is are equal, right? Then that means there's a cycle. So it's a pretty simple, we can say, concept. So let's start with the code, right? Let's first define these fast and slow pointers. So slow, let's keep both the pointers at the head position itself, okay? So that it's easy for us, okay? Let's name it as fast, okay? And let's just initialize an while loop. We'll go until fast reaches the end, right? If fast not equal to null, we'll just terminate the loop. It can may happen that so it can may happen that if let's assume there's no cycle, right? Let's say there's a node, there's another node, and there's another node. Okay, so let's say fast is here and there's no cycle. This is pointing to null. So if fast go jumps by two position, it will eventually reach null, and then the value fast dot next will give us a null pointer error, right? So here what we can rather do is basically we can state that if fast dot next, okay, is also null. Sorry, so fast, let's say fast is here, right? So so if we see fast dot next is null, right? So if we move fast equal to fast dot next, right, to move to the next loop, this will throw an error because fast dot next is actually a null value, and we can't assign the null value directly. It will throw an error. Okay, so that's the reason we have to also put and fast dot next is not equal to null, right? That will make sure the loop terminates properly. Okay, now we have initialized a basic loop. Now what we're gonna do is basically we're gonna move fast and slow pointers, right? So what we're gonna do, let's move our fast and slow pointers. We're gonna do slow equal to slow dot next, right? And we're gonna do fast equal to fast dot next. That means it's jumping by two positions. Now we're gonna check if fast and slow pointers are equal. If they're equal, that means there's a cycle present, so we can just return true. If there is no, if they do not coincide, right, that means we're gonna move to the next position. So if the loop is continuously going, right, uh, that means if it terminates, that means it has reached the end of the loop, end of the linked list. That means there's no cycle present, so we can just define false outside the loop, right? And yeah, that's the pretty much cool. Let's just check for any syntactical error if there are any present. Okay, so there's no error. We can just submit the code and let's check for the rest of the test cases. Okay, it's properly working right now. So if we see the space complexity of this is obviously just O of one time, right? Because we are not storing it anywhere, we are just defining two pointers, slow and fast. So it's just O of n space complexity, and the time complexity is obviously O of n, where n is the length of the, we can say length of the linked list, right? So it's just traversing the linked list one by one. So yeah, that's a pretty good algorithm we can say just to remind, and we can say in linked list problems it's fast and slow pointers, or we can say hare and tortoise algorithm is really very useful to determine either the if that is in cycle, to determine also to determine the midpoint, let's say, because fast and slow basically move by 2 points, right? So when, let's say, let's assume there's another node, okay? That's another node here, and that's no null value. So when fast reaches here, this low pointer will reach over here. So that's basically, we can say, kind of like a midpoint to divide the list into equal parts, okay? So if you want to divide the list into two separate parts, we can use this fast and slow pointers. So that's really useful. So yeah, that's it for the algorithm. Thank you.